Let's move on to our next question by opening up the Anagrams directory. Inside of here, I'll open up the index.js file, and then as usual, let's also start up our tests. So back at the command line, we'll run jest anagrams/test.js -- watch, like so. And we should see a handful of tests start to run. So in this case, 6 total right now. Cool, so let's give this thing a shot. Let's take a look at the directions and examples to start. Now, you will recall we briefly spoke about anagrams during one of the earlier exercises. So we're kind of coming back just to kind of reinforce the idea of working with strings, specifically around creating and working with character maps. In addition, working on this anagrams question is also going to start to frame one of the larger discussions about interview questions that we're going to see very frequently in the later half of the course. So this is not only a review, but also kind of forward-looking stuff that we're going to go through. So let's take a look. Our goal here is to check to see if 2 strings are anagrams of each other. Remember, an anagram is where we take one string and then generate another string out of it that has the same number and quantity of characters. So for example, if we took the string rail safety and jumbled those letters into the string fairy tales, they both use the same number and quantity of each character. So for example, I will find exactly 1 R in both strings. I will find 2 A's in both strings, and so on. You get the idea. Now, some special directions on this question in particular is note that we only want to consider characters. We don't want to consider spaces or punctuation like, say, exclamation marks or anything like that. So we can completely disregard exclamation marks and spaces. In addition, we want to consider capital letters to be exactly the same as a lowercase character. So the second example right here is a great example of both those 2 rules. So you'll notice right above we have rail safety and fairy tales are anagrams. The second example right here has still rail safety, but with capital letters and exclamation marks. However, we should still consider this to be an anagram of the lowercase fairy tales. Now, just to make sure that you start down the right path, I want to give you a couple little tips for dealing with these kind of edge cases around characters and not spaces or punctuation, and also a quick tip around capital letters as well. So let's flip over to my browser really quick, and we're going to look at some examples here. So the first thing I want to give you a quick note on is on the MDN documentation, we have regexes, which is short for regular expressions. Regular expressions can be used to manipulate strings very easily. And in this case, we can use a regular expression to very easily remove all these spaces and exclamation marks from a given string. So in this regex article, I'm going to scroll down a little bit, and one of the items inside of here, right here, so \W, specifically shows us how to match only characters and completely disregard any type of space or any type of punctuation or other symbol for that matter. So let's see an example of this in practice. As a quick example, let's say maybe we have a string called word, and it is the string hi there. All capitals with a lot of exclamation marks and a space in between right here. So we can very easily remove the space and all the exclamation marks from this thing by calling word.replace, and they'll make use of a regular expression inside this. So I'm going to place a /, a square bracket, a caret, \W, a closing square brace, /G. And then we will replace any characters like that are found with an empty string. And so you can see that very easily that removes all the extraneous characters from the string. So it gives us something a little bit more cleaner to work with. Now the other thing to keep in mind is that we only want to work with lowercase characters. So a very easy way of making sure that we are working with a lowercase string would be to chain on the method to lowercase, like so. And so essentially with these 2 methods right here, we can take a string that is capitalized with spaces and punctuation inside of it and reduce it down to just the bare characters like so. So I really expect you will end up making use of these 2 methods right here in your solution. So essentially copy these things down because I really expect you're going to need them. Now, the other thing I want to mention, just as a reminder about how we generally like to solve any type of question involving strings and comparison between them, is to generate character maps. And that was something that you'll recall we did earlier on in this course. So just as a suggestion, one possible way, and this is just one way, there's more than one way to do this question, but one possible way is to generate a character map out of both the strings that you are given. So for example, if we are given the strings hello, and I don't know, but this is supposed to be Liho, I guess, I don't know. If we build a character map out of both these, we would end up with one H, one E, two L's, and one O. And we would get the exact same character map for Liho as well. So we could iterate over one of these character maps and compare all the letters inside of it with all the letters in the other one and the quantities as well. So I'll leave that one up to you to kind of get through a little bit and figure out. So there is one last little gotcha around the character maps that you're going to generate here if you decide to go with this method. So let me show you what this kind of edge case is. When I just told you that you would want to compare these two character maps, you might have thought, okay, we can iterate through this object right here and then compare all the properties and values with the properties and values in the other object as well. So there's one little edge case that I want to throw out there just so you are aware of. Imagine the case that we were going to compare these two character maps. So notice I just changed the diagram. The word over here on the right has changed to hellos, so it has an extra S on here. Now imagine if we wrote a loop to iterate only through this object. If we only iterated through this object, we would look at the character H, see that it has one use, and compare it over to this object. We would say, okay, this one has H as well, and it has one use as well. We would then repeat the process for E, they're the same, L, they're the same, O, they're the same, and that's it. We've now finished iterating through this object. But notice how we completely missed the fact that this other character map has an extra S on it. So one possible way of solving this problem is to compare first this character map to this one, and then iterate through this character map and compare it to this one. However, there is an easier or kind of a little shortcut that we could use to avoid that. So we don't really have to do a comparison one way and a comparison back to the other. If you want to know what that little trick is, I'm going to say it right now. What we can do is count the number of keys that are present inside of one object and compare it to the keys that exist inside the other. So for example, this key over here has 4 letters inside of it. This one over here has 5. And then another very obvious way of handling this would be to count the length of characters inside this string and compare it to this one over here. So just 2 ways of addressing that issue. Okay, so we've laid out a couple notes here. Now this anagrams question is a rather challenging one, so do give it a shot. But as usual, if you get stuck, feel free to check out the solution and we'll walk through how to solve this thing together. So quick break and we'll continue with the solution in the next section.